Hello everyone, my name is Bilal Arshad. I am currently working as an Associate Research Fellow at the University of Wollongong. I'm also a founder and director of Wize. At Wize, we create AI-enabled computer vision applications for the conservation of biodiversity. Let me take you through the poster presentation. The topic of today is Where is my deer? Wildlife tracking and counting via edge computing and deep learning. So why wildlife monitoring is important? Estimating the abundance of wildlife species enables researchers, environmentalists, and ecologists to establish conservation and adaptive management strategies, the basis of which is an accurate count of the animals present in a specified region. In recent years, various computer vision technologies have been developed to replace the manual identification and counting system. The existing approach to the deer counting problem is via analyzing a single image. Such an approach results in an inaccurate count due to the recounting of the same individual animals multiple times due to the reappearing in other images taken by the same or other trap cameras. To overcome such limitation, we have utilized a novel approach of using video as an input and deep learning techniques to detect and track deer movements within the field of view of the camera. The reason of using video as an input to the algorithm is because it provides contextual information, and as long as deer remains within the field of view of the camera, it will be counted only once. The block diagram of a remote sensing device designed for this project is shown in Figure 1. Now I briefly explain the identification and tracking pipeline. The first step of our proposed approach is the identification, which is also a prerequisite of tracking by detection-based methods. We have utilized our YOLO v3 identification purposes. To track deer movements, we have adopted an online tracking-based method, discriminative correlation filter, to track deer movements within the field of view. The reason of tracking deer movements in video frames is to avoid giving it a new identification ID in follow-up frames. Having a good tracking algorithm helps in an accurate count and minimize the risk of recounting of the same animal. Now some results. During the 14-day field trial, 17 out of 20 deer were correctly identified and counted with the recounting correction applied, thus proving our approach for removing recount is viable. Thank you so much for your time